Dear Distinguished Chair, colleagues, and guests, my name is Nguyen Phuong from Faculty of Civil Engineering, Hanoi Architecture at University. Today, I would like to present our research co-authored with Dr. Dao Minh Hieu, entitled Application of BIM Technology in Construction Schedule Management for Industrial Projects in Vietnam. Our presentation is organized into 5 parts. First, an introduction of BIM adoption. Second is our research solution. Third, the development of four-dimensional BIM model for industrial construction scheduling. Fourth is our research result. And finally, in our conclusion. Let's begin with the introduction. Building information modeling, or BIM, has been adopted globally at an increasing rate over the past decade. Many countries have moved from voluntary use to mandatory requirement on public projects, recognizing BIM model in improving design coordination, reducing error, and enhancing proficiency across the construction life cycle. In Vietnam, this trend is reflected in a clear implementation roadmap. The international standard ISO 19650 provides the foundation for information management, while Decision 258 and Decision 347 issued by Vietnamese government establish the national roadmap for mandatory BIM application in construction projects. Based on the BIM implementation roadmap issued under Decision 258 on March 17, 2023 for public funded and state owner project, a mandatory BIM application applied to grade 1 and special grade structures from 2023 and grade 2 and above structures from 2025. For other funding resource, private or foreign investment, mandatory BIM application apply grade 1 and special grade structures from 2024 and grade 2 and above structures from 2026. Next part is research solution. We identify both subjective and objective advantages favoring four-dimensional BIM adoption in Vietnam. On the object side, BIM is considered a flagship technology for the global digital revolution. Earning strong confidence in its potential from industry experts, Vietnam can leverage valuable lessons learned from international BIM projects. The government highly supports BIM adoption by establishing regulation, learning forum, and implementation mandatory policy. On the subjective factor, Vietnam people can naturally agile and quick to adapt to new innovation. The young, enthusiastic generation of engineers tend to rapidly catch up with global technology. Based on the advantage, we propose the structural four-dimensional BIM implementation process for construction scheduling, which links three-dimensional geometric model with time-based schedule data to simulate the entire construction sequence. Several software platforms support this process, including Latticeworks, Synchro, and Assemble System. Four-dimensional BIM allows users to integrate three-dimensional design models with schedule information, providing an effective approach to managing both information and time throughout the entire project lifecycle. Now, let's look how we develop our four-dimensional BIM model for industrial construction scheduling. Our development process consists of four main stages: three-dimensional modeling, detailed construction scheduling, model schedule integration, and simulation, which I will walk through one by one. The architectural model have precisely controlled spatial area and volume and supports multidisciplinary coordination, while the structural model ensures low bearing capacity and stability critical for industrial projects, with typical carry heavy machinery load and feature-length structural span. We elaborate to build with the model directly from two-dimensional drawing with a clearly agreed level of development to ensure sufficient detail for later analysis. Here you can see the resulting architecture model, including the first floor plan, elevation, profile view, and all developed within a coordinated three-dimension environment. Similarly, the structural model was developed with corresponding floor plan, elevation, and profile views, ensuring full alignment with the architecture design. The MEP model covering mechanical, electrical, or plumbing system was then developed from AutoCAD schematic diagram and built on top of the structural and architecture model, ensuring consistency across all disciplines. With the three-dimension model complete, we move to detailed construction scheduling. A proper schedule must include project deliverable, resource management, and allocation, the tasks required for completion, interdependencies between tasks, deadline and milestone, and budget-related factors, all essential for accurate and reliable four-dimensional simulation. We use specialized scheduling software to build and manage the schedule through network diagram and Gantt chart. This allows us to easily adjust the plan as real-world change occurs, generate quick report, and manage multiple Phuong projects while handling changes in task duration, constant, and resources. Schedule control follows an input process output framework. Input include the project management plan, project schedule, and work performance information. The process will involve performance estimation, change analysis, and schedule update. And output include the performance assessment, change request, and update the project documentation. We apply this framework in practice using Cycro software on a real project by Licogy company. Cycro links the schedule with the manpower, materials, equipment, and construction space, enable easy to comparison against the baseline plan, visualize the entire construction process, and integrating with tools such as Oracle, Primavera, and Microsoft Project. The final four-dimensional model was set up by combining the three-dimensional architecture and structural model, creating them and running a construction project simulation, giving stakeholders a clear time-based visualization of the entire building sequence. Our research shows 6 key benefits: visual schedule management that help track and adjust program, early class detection between structural and architecture and MEP system, risk mitigation through field error and delay, optimize use of resources and site logistics, stronger coordination among the stakeholders, and a solid foundation for the future 5-dimensional and 6-dimensional BIM application, covering cost and facility management. Effective coordination requires clarity among all key stakeholders: the project owner, architecture and structural design consultants, the BIM coordinator, and the construction unit, and other related parties. We establish the Common Data Environment, or CDE, using Autodesk Construction Cloud, with improved productivity, save time and cost, strengthen data security and consistency, and enable online viewing, collaboration, and approval, all in one centralized platform. Comparing traditional data exchange methods, the CDE platform greatly simplifies building visual model, design coordination, and class detection, easy and convenient drawing management, and overall drawing management. Our study confirmed that stakeholder coordination is essential for successful four-dimensional BIM implementation. Based on ISO 19650, we process an information management structure center on CDE, where the client and project management board serve as the primary coordinator, connecting designer, contractor, and supervisor through a single source of truth. The diagram summarizes the coordination relationship among all project stakeholders on the BIM platform. In conclusion, our four-dimensional BIM approach visualizes the construction sequence, optimizes on-site management, enable flexibility, flexible online collaboration, and support real-time decision-making while requiring standardized data and personnel skills in tools such as Navisworks work or Synchro. After a 10-year period of research and analysis, I'd like to invite everyone to watch a short video. This video demonstrates that the practical application of four-dimensional BIM simulated using Synchro software to give a clearly look how scheduling and three-dimensional model integrate in a real time. That brings me to the end of my presentation. Thank you very much for your time and kind attention. If you have any question regarding this research topic or any feedback for me, please feel free to send me to my email address. I will be more than happy to review and respond to your query as soon as possible. Thank you once again.